Meet my robot. Built around a quad omnidirectional motor drive, it was made to compete against the very best in the Robocup competition. With 2 dribblers, 2 kickers, and an omnidirectional camera, this robot placed second in the world for open weight. This is not my project, because it is garbage. The frame is too high, dribblers too weak, and one of the kickers doesn't even kick properly. It also has a problem where if you hit it hard enough, the buttons will go all wonky and the entire thing shuts off. Like, what? Why? How does this happen? Come on! That's why I'm making it better. But first... So this is the new design. As you can see, it's similar yet different from the older version. It actually possesses a number of improvements, including a more optimized design, more features, better stability, and a lighter weight. And so I initially had the idea to complete everything and build it. But then, COVID-19 happened. The supply chains for a lot of what I needed to make disappeared, meaning all that I had left was a series of incomplete components and designs. So essentially, that's what this project is going to be about. One of the biggest issues with the old design, the buttons didn't work. So when creating the previous design, I split the PCB into 2 sections, with the buttons on the top and the main processor on the bottom. The issue? The connection was really dodgy, meaning the signal would randomly flicker and cause the robot to brick in the middle of the game. And if you can't tell, that isn't a good thing. So the first thing I did was take the old PCB and then I started working from scratch. Essentially, the new design incorporated both layers into the same PCB, getting rid of the connection issues. I also replaced the processors, exchanging the 2 Teensy 3.5s with a single 3.5 and 2 of the new 4.0s, thus increasing the number of processors from 2 to 3. Because more equals better, obviously. The new design also incorporated a number of features, including more buttons and LEDs for better controls, a space for a Bluetooth module allowing communication between robots, and a small accelerometer, saving on weight. It also has a giant hole in the middle of it. We'll get to that later. Next came the light sensor. The old one was nice, except for the fact that it was too tall, too fragile, and had this weird offset shape because I had to fit an entire processor under there. Essentially, it was all around not a good design. They also had another really annoying issue. So when I was designing the original one, I was like, okay, you know what'll be a really good idea? Using some red LEDs because they offer the greatest contrast against a green field. Big brain move, am I right? As it turned out, nope. The color of the LED plus light bleed caused another issue. Essentially, ball equals orange, LED equals red. Robot cameras are bad, therefore orange equals red. Thus, other robots think ball equals LED, which is a big no-no. Last year, we had to try and make do with electrical tape, and I was seriously not interested in going through that hassle again. So the solution? To stick with the old white LEDs. And hey, while I was at it, I decided to add some more light sensors as well, increasing the number from 24 to 32. Now that that was done, I decided to tackle another issue. The fact the light sensor looked like a flattened popsicle. Now, in previous years, I placed the light sensor teensy at the bottom for convenience, but this year I decided to put it at the top instead, making it easier to access and replace because boy did it take a long time to fix. And if the fact that we had an entire pile of broken teensies was anything to go by, we burned through these faster than stores selling toilet paper. There was also the issue of cables, so to resolve this, I used a multiplexer. A multiplexer is essentially a switch which connects one read wire to multiple sensor connectors, changing the 24 wires needed for the 24 sensors to 10 needed for 32 sensors. All in all, a pretty good deal. Now, another issue I attempted to address had to do with the robot's ultrasonic sensors. Ultrasonic sensors are used to measure a distance, and placing one on each side of the robot can help you get its coordinates on the field, letting it know its location. But there's one big problem. As soon as something goes in between the sensor and the wall, everything starts falling apart. The robot doesn't know which is the real value and which is the incorrect one, and the location becomes lost with the entire thing going all whack. So what's the solution? Well, if measuring 2 values isn't good enough, why not measure all of them? Now, this sounds a bit crazy, but hear me out, okay? This is the Slamtech RP LiDAR. It costs a lot of money, but hey, I got it on sale, so might as well use it. It is essentially a spinning distance sensor, allowing someone to measure a distance in a 300-degree radius. That way, even if a range of values is blocked by another robot, the sensor can just see around it. Finally, I had to address the issue of the dribbler's power. I mean, the motor torque was pretty good, but since the speed was so slow, the grip on the ball was usually quite shoddy at best. The previous solution was essentially to tighten the dribbler's elastics and increase the downward force pressure, thus allowing it to hold the ball with a tighter grip. But this was only effective to a point before what happened was, instead of applying more force on the ball, the elastics would just lift the robot up, causing the ball's backward motion to push the robot back, and yeah, it wasn't gonna work. Also, the dribbler was like 300 grams, which was super heavy for a competition where the max weight is 2,400 for an open league robot. The new dribbler is both lighter, weighing in at about 200 grams, and also runs at a considerably faster speed. Like, it's scary how fast it runs. This design is a significant improvement over any previous designs and allowed the robot to better grab and hold the ball. While I was doing this, I also upgraded the kickers as well. Previously, we had a front kicker that was good, but due to weight constraints, used a smaller kicker in the back, which was quite wimpy and essentially useless. This time, we used the same kicker for the front and the back, making sure that it could kick well in both directions. Ultimately, through a series of trial and error in identifying specific issues with the old version, I was able to create a more efficient and effective new design, with many technological and strategic improvements that help it become a more effective robot in the competition. Now, if only I could have actually used it, in the competition, if it weren't cancelled. Anyways, that's it for the project. Thank you for coming to my TED Talk.